So, with the name of God, Ram Ram. Yes, guys, you heard it right that Infosys asks the hardest online assessment problems. Okay, Infosys OA is even harder than Fang OA, and most of the Infosys OA I have found them harder than Media.net and Coordination OA as well. Media.net and Coordination asks the hardest OA, but Infosys has crossed the level of everyone. Though they just offer a package of 5 LPA, 6, 7, 8, 9 maximum, the OA problems they ask are, give you a feeling that you are giving an exam for a company for 50 LPA or somewhere in the range of 1 CR. Okay. So the nice thing is that I always tell my students that always practice Infosys OA problems, because if you can do this, rest all will be easy for you. Okay. So let's discuss an Infosys OA problem. Okay. So, guys, the name of the problem is Max Network Engagement. You are manager of a social network comprising of end users. The users are organized in the form of a tree with user 1 as the root. It is given that each user I has a certain engagement level, val of I. ENG total of I is the sum of the engagement level of all user J that are blah 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 blah. They have given you such a hard tree problem and it is so difficult to understand. My goodness. Anyways, let me make the question easy for you. Okay. Understanding of the problem, guys. Now, listen to me carefully. Okay. Yeah. So, guys, the thing is that if you try to focus on the understanding, they are saying that you are given a tree. You are given a tree with n nodes, and a tree always has n minus 1 edges. Guys, this problem has many prerequisites. Okay, so I assume that you have watched my basic DFS and BFS and graph videos, or else you're not gonna understand this. Okay, you are given a tree with n nodes. Okay, that's clear to you. Okay. Each node has a particular value. You have to find sum of I for each node. Sum of I for each node. Sum of I for each node. Which means, which means, which means, which means sum of all the nodes in subtree of I. Okay. Once once that is done, once that is done, once that is done, find the frequency of maximum number and output it. So guys, how will be the algorithm design? See, you are given an tree like this, which is rooted at node 1. So let's say this is your tree. Okay, node 1, node 2, 3, 4, 5, 6. Okay, this is your general tree. Okay, it is not binary, it can be general. Okay. Let me erase the numbers given inside the nodes. Okay. We need to do that. Okay, we need to do that. The actual number of the node I will write outside. Okay, and the inner value, let's write it here. 5, 8, 6, 1, 4, 5. No, 2, 3, 4, 5, 6. Guys, node number 1 has a value of 5. Node number 2 has a value of 1. Node number 6 has a value of 6, and node number 3 is value of 4. Node number 4 has a value of 5. Node number 5 has a value of 8. Now you want to find, you need to find another set of values which will tell you the sum for each node. So what will be the sum for this much part? It will be 5 only, right? So it will look like this. What will be the sum for this much part? 5. So I will write a 5 here. Now I'm making the final set of values which we need. What will be the sum of this much value? It will be 8, right? 8. What will be the sum of this much value? For this node I, if you want the sum of all the nodes which are coming below it, and this node also, 4 plus 5 plus 8, which is 17. For this node, it will be 6, but for this node number 2, value is 1, so it will be total 6 plus 1. Okay, that is called as the subtree sum of node I. Okay, so 6 and 7. And guys, this node will be nothing but the sum of all the nodes in the tree. For this node, you have to, the subtree of 1 is nothing but the whole tree. So guys, I hope you understood what is the meaning of subtree of node I. Subtree of node I means sum of all the nodes, including the node I, which are coming below that node. Okay, so this will be 5 plus 1 plus 4 plus 6 plus 5 plus 8. Basically, if you are doing the DFS algorithm, it will be 7 plus 17. Okay, 24, right? 24, guys, 24. Now you please find the frequency of everything. So it looks like 24, 7, 17, 6, 5, 8. All the numbers are coming for one time only. So the output of this problem is 1. Got the point, guys, lovely people? I hope you understood. Okay. So let's discuss one more example. In this problem, we are not going to write code because many beginners are also watching my video. Okay. They will go into, lots of stress if they see this complicated concept in code. So I'm just trying to explain you the design of the algorithm, how the algorithm should look like for this problem. Okay. So, guys, again, I'm giving you a treat. This time, lovely people, you have to tell me. You have to tell me what will be the subtree of node I for each node. Okay. Guys, tell me please. For this node, the sum will be 1 only. So let's write a 1 here. Ha ha ha. For this node, sum will be 5 only. 5. But guys, for this node, you have to find the sum of both the nodes. See, subtree of I means this node and all the nodes coming below. So 5 plus 5, 10. For this node, it will be all this part. 0 plus 5 plus 5, 10. And guys, for this node, the whole tree. Because the whole tree is below this 5 node, right? So it is 5 plus 5 plus 0 plus 1, which is 11. Okay. Now, lovely people, please tell me how many times each number is coming in this node. 11, comma 10, comma 10, comma 1, comma 5. Every number is coming for one time except 10. 10 is coming for two times. So highest frequency possible is 2. So I hope you guys understood the easy level understanding of the question. Okay. So algorithm design. Algorithm design. Okay. The actual problem is much harder. We are solving the easier version of the problem. Okay. You can do a simple DFS. Okay. Create an array, sum, where sum of I will tell you sum of all the nodes in the subtree of node I. It is assumed, no, it is not assumed, the tree is rooted at node 1, means the tree starts at node 1. Okay. So this is clear, you people. Okay. So do a simple DFS. Do a simple DFS, and in O of n, find all the sum of I. The formula which you should use is in the DFS. The formula, you don't need to understand it in depth. Just understand it from an upper level for now to get the gist of this problem. The formula will be what? Sum of I is nothing but sum of C1 plus sum of C2 plus sum of C3 plus uh, value of node I. So guys, the subtree sum, if you want, na, see, you can use common sense here, that this is the tree, right? Okay. Now, this is, let's say, 1, 2, 3, 4, 5, and 6. Okay, and this is, let's say, 8. Okay. So now, if you want to find the subtree of some this guy, it is nothing but sum of it is going to be the sum of its children subtree. Sum of its children subtree means sum of 2 plus sum of 4. So both the subtrees will be added. Sum of 2 plus sum of 4 plus the value of node 8. But the value of this node, what is the value of this node? 8. So plus 8. What is sum of 2, guys? If I write equal, sum of 2 is nothing but 2 plus 3 plus 1, which is 7, plus sum of 4, which is 4 plus 5 plus 6, which is Devin AI. I don't fear. 4 plus 6, 10 plus 5, 15, plus 8. 8 is the current value of the node. So what will be the answer? 8 is 16. So 8, 7, 15, 30. So guys, sum of 8 is 30, and you can cross check. 8 plus 2 plus 3 plus 1 plus 4 plus 5 plus 6 is 30. So for any subtree in the DFS now, you just have to apply this formula that if you are at a node I now, travel through all its children. Okay, add the sum of all of its children and the current value I, and you will be easily able to solve this problem. And the things will be very easy for you people if you do it in such a manner. Okay. So what happens in DFS, I'll try to show it to you. Okay, even though this is very complicated to explain to the beginners, still. So guys, in DFS now, you travel the tree in a boundary manner. Okay, in a boundary manner. Boundary manner. So you are here, you come here, then you come here, then you come here, then you come here like this, Like this, guys, like this. I hope you are enjoying. Like this, and like this. Okay. So what happens is that when you are again going up, na, when you are trying to go up in your DFS, at that time you will calculate the sum. Got my point? For example, let's say this is your tree. No one will explain you in such depth what I am doing for you. In the recursive function, DFS is going like this, right? But when it will start going up, at that time you will start calculating the sum of the subtree. So for this last node, nothing will happen. But when you are going up here, now you can see that this is this guy's child. So child plus current value, some value you got it. When you are going up, you can see that this guy is actual child of this guy. So this guy plus sum of this. Okay, why to calculate the sum of this previously? Because you need the subtree sum of lower level before the upper level, right? So if you go in this manner, na, for each node, very easily you can calculate the sum of I. Okay. For deeper analysis of these algorithms, you can watch my videos, or if you are my like 800-hour course student, then all the things I've explained in very details in the videos, so you can check them out. So now listen to me carefully, okay? I hope you understood that complicated concept, that even though you don't understand the exact details, but you do understand that Kumar K is finding in O of n all the sum of I. Just assume that I'm able to do it correctly. Okay, clear. So guys, this is very easy, right? Once this is done, now put all the sum of I in hash map, and whoever has the highest frequency, and whichever element has the highest frequency, that's the answer. That's the answer for now. But guys, the Infosys problem is very hard. They are saying that condition is also applied. You are allowed to change value of at most one node. So guys, you have to maximize the frequency by changing the value of at most one node. Okay. So this is so complicated, man. Oh my goodness. Let's say you have a tree like this. The actual value I'm writing outside, and inside I'm writing the sum of I. Okay. So guys, these are the values of the nodes. Okay. So uh, all you got to do is find the sum of subtree, right? So this will be 10. This will be 10. This will be 2. This will be 12. This will be 8, 10, 18, and 10 plus 8, 18 plus 2, 20. 20, guys, 20. 20 plus 12 is actually 22, because 2 is also getting added, no? And then it is 22 plus 12 plus 5. Let's write it here as 6. So This is 22 plus 12 is 34. So 34 plus 6 is 40. So here it is 40. Now, guys, you are even allowed to change your value. You're allowed to change your value also. What will happen if you change the value of this node? Just think about it. What kind of dread it will be. If you change its value, just think which sum of I will be affected. That is the observation you have to do. Okay. Observation is this is only for very high level coders, not for beginners. If you change value of node I, if you change value of node I, which sum of I values will change? Which sum of I values will change? Which sum of I values will change? Answer is all the ancestors of node I will change. All the ancestors of node I will experience a change in their sum values. So guys, आप भी थोड़ा दिमाग लगा लो. आप यहाँ पर हो, अगर आप इसको अभी बदल दो, अभी करंटली वैल्यूज कहाँ है, क्या है इसके, व्हाट आर ऑल द एंसेस्टर्स, आई विल शो यू इन द डायग्राम. Guys, by the red marker I'm showing you the ancestor of this last node 10 na, which I marked with black color. These are all the ancestors. Now if I change this 10 to 20 na, all the ancestor will change. Let's say I change this to 20. Okay, basically I put the value 20 here for this node. Okay, then what will happen, lovely people? All the values are gonna change. This will become 20. This will become 20 plus 0, 20. This will become this is 20, this is 2, so 22, and 22 plus 12, uh, 32, 34. Okay, this will become 34. The values are changing, and this will also change. Okay, it will be now 34 plus 22, 56 plus 6, it will become 62. So guys, you can see that full branch will change. Okay, so this is the biggest observation for the problem, is that this is common sense. Guys, listen to me. I'm actually very ill from the last 2 to 3 days. Still, I'm making sure I record it for my people. So, guys, listen to me carefully, okay? If I take the red one in, red, if I change the value of this node, which sum of I will be affected? It is common sense. If I change this value, all this node and all its ancestors sum of I will change. Why it is happening? तुम ही दिमाग लगाओ ना. If you change this value, obviously its sum of I will change, the sum of all the nodes, because it includes the current value of node. Now because you have changed this sum of I will also change, because the sum of I means this node plus the sum of below nodes. अब नीचे वाला ही बदल गया तो ये नहीं बदलेगा. The below node changed, so this node sum of I will also change. Got it? Because sum of a node is nothing but its current value plus sum of all its children. Now if children has changed, you will also change, right? So when you change a node red color na, all the black color nodes change. This will also change and this will also change. So I hope you got it, that whenever you change a node value, all its ancestor gets changed. Okay, now what is the solution? Okay, do a very complicated DFS. Do a very complicated DFS and use multiple hash maps and multi sets or ordered multi sets in C++, Java, Python. You need to find it out, figure it out, and maintain the frequency of everything. This is brilliant. DFS traveling makes it very easy. When you reach node I, when you reach node I, okay, when you reach node I, uh, please make sure in your hash map one has all the sum values of the ancestors of that node I. Okay, and hash map 2 will have values of all sum. Okay, will have values of all the sum values of all the nodes except the ancestors of I. See guys, I will tell you how it looks. Let's try to make it easy. Okay, let me take one more easy example. Okay, so listen to me carefully. Okay, okay, okay. Guys, these are the values of the tree. So quickly let me write the sum of I value. What will be sum of I? It will be 10. Okay, 10, 10, 1, 2, 3, 4, and 25. Now in the hash map 1, now all the values with the frequencies will be written. So 25 is coming one time, 10 is coming three times, okay, 1 is coming one time, 2 is coming one time, 3 is coming one time, 4 is coming one time. Okay. Now, lovely people, you start doing one. DFS is already done one time. Now let's do DFS second time. While doing second time, na, I will assume that I have changed the value of node I. Okay. Sorry for explaining it in such a fast manner, but we have to do it. Okay. So guys, your DFS starts here. Okay. At the first node, whatever happens, what happens at the first node? You only see, na? What happens at the first node? You see that 25 is coming for one time, right? Right, lovely people. So in the second hash map, you write that, yeah, if I travel till here, then 25 is coming for one time. Okay. Then, if you go below in the DFS, you can see that here there is a 10, and you can say that, yeah, 10 is coming one time. Okay. And guys, simultaneously, now you need to reduce the values from the hash map number one. Okay. Hashmap 1 has the frequencies for all the numbers in the tree, but as soon as you again do the DFS, na, please decrease those things from Hashmap 2. Okay. See, earlier Hashmap 25 had 1, na, but now have you traveled it again? You write it as 0. No, it is not there. 10 was 3, na. Now you write 10 as 2. Okay. 1 one time, 2 one time, 3 one time, and 4 one time. Okay. And 10 is coming as now only 2 times. If we ignore the black part, you have traveled this black part. So you remove the black part. Remove the black part from first hash map and put the black part in second hash map. Black part is 25 and 10, 25 coming one time, 10 coming one time. So it is in another hash map. And 25 is now 0 time and 10 is now 2 times in the second hash map. So guys, I hope तो आप लोग समझ गए कि जो हमने ब्लैक ब्लैक पार्ट ट्रैवल किया है ना, ट्रैवल वाले पार्ट की जितनी भी वैल्यूज है वो मैं दूसरे एस मैप में डाल रहा हूँ और पहले एस मैप से उसको निकाल दे रहा हूँ. ओके. ओके. Now guys, let's see what will happen if I travel in my DFS till the end. I come to the last 10. What will happen? 25 will be coming one time and 10 will be coming three times. Okay? Yeah. Here 25 will be 0, 10 will also be 0. Okay? Okay? And let's say this number was also 10 only. Okay? And let's say this number was also 10 only. Okay? Now, in total, 10 is coming for 5 times, right? 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 So, in the path not travel, 10 is coming 2 times. And in the path travel, 10 is coming 3 times. Now, guys, you can instantly tell what will happen if you change the node of value of this particular node. You will try to change the value of each node I and find the best answer possible. For now, let's assume what will happen if you change the node this value. Okay. So, in short, you will try to change each node value and see what's the best answer you could get. Final answer will be maximum of all the best possible answers. Okay guys, okay. So here you're trying to change the last guy. So guys, you only use your brain. If I change my last guy, let's say I make it 20, then what will happen? All the numbers will get affected, right? All the freaking numbers are gonna get affected, right? But you should know that how are they going to get affected. For example, this is the vertical part which I have traveled in my tree, and if I know that all the values are like this. 25 is coming one time and 10 is coming three times. Okay. Now you only use your brain. If I change this value, what will happen? This 25 comma 1 will become a different value y comma 1, and this 10 comma 3 will become x comma 3. The values will change but the frequency will remain the same. चाचा जी फीलिंग आ गई बताता हूँ. So let's say this was 5 and this was 0, 0 and 10. So what is the sum? 10 here, 10 here, 10 here. Okay. Okay, and this is 15 here. Okay. So the hash map is looking like 15 comma 1 and 10 comma 3. Now If I change the value, if I make it 5, then what will happen? This sum will be 5, it will be 5, it will be 5, and it will be 10. So now the new hash map will look like this, that 10 is coming one time and 5 is coming three times, guys. But can you see the similarity? The highest frequency remains the same. Earlier some number was coming one time and then some number was coming three times. Now also some number is coming one time and some number is coming three times. So guys, so whenever you are trying to change a node I value, it does not matter. It really does not matter at all. You should try to really focus in depth. Really does not matter at all. Okay. So guys, the actual solution is pretty simple. Okay. Uh, see, the actual solution is that this is a tree. Okay. Now you have traveled. Now let's say you have traveled via DFS. This much part you have traveled. Okay. This much part you have traveled. Okay. And the blue part is the part of the first hash map. Okay. So the first hash map is showing you that there is some number. Let's say both the values are same, which is coming two times. Okay. And the black hash map, the black hash map, guys, shows you. The black hash map shows you, guys, that this is the second black hash map. Okay. Let's say it is saying that there is a number y1 coming for 5 times and y2 coming for 8 times. Okay. Okay, lovely people. Now listen to me. Now listen to me. Let's say you try to change this value. Change. Even if you try to change, lovely people, it does not matter. Because there will be some other number y1 dash here, another number y2 dash here. Still the frequency will be 5 and 8, right? So take the highest frequency here, 8, right? Right? 8. And what is the highest frequency here? 2. So I will try to change this node in such a manner that y2 dash becomes equal to x. If y2 dash becomes equal to x, then my job is done, because x is coming 8 times in the black part and x is coming 2 times in the blue part. If I add their frequencies, it will become 10, and 10 is my answer. So via DFS, I will travel the whole tree, and for each node, I am going to do this thing, and I am going to enjoy my life, because I now know what will be the answer if I change each and every given node. Okay, so I will tell you. Okay, uh, okay. First, I travel this node. I will check what will be the answer if I change this. Then I will travel this node. I will check what will be the answer if I change this. Then I will travel this node. I will know what is the answer if I change it, because I have the data of all the ancestors. Then I travel here. I will check what will happen if I change this, and then that's it. And then, guys, when you are again going back now, again going back, then you have to again change your black hash map 1 and hash map 2, as now this node is again being ignored. Okay. Then, guys, मतलब रेड पार्ट बदलता रहता है. Okay. Earlier the black part is this much. Okay. Then it is this much. Okay. Then it is this much. Okay. Then it is this much. But then when you're again going up now, the black part is again this much. I will show you it by the red part. Now when you're going up, only this much part. Basically, whatever is this node's value of sum of I now, you please add it back to the first hash map and remove it from the second hash map. Then you go up again only this much. Then you go up again only this much. Then this. Then this. Can you feel the DFS? Then this and then this. Then again, when you go up, you keep on removing. So that, what does this ensure? This ensures that no matter how large and big your tree is, no matter how large and big your tree is, no matter, when you are at this node I now, the black hash map will only have the details of this much part. Why? Because it has traveled in that way only, right? It went here, then it again removed those values. It went here, again removed the value, went here, again removed, again here, then here. So the black part will have only the ancestor hash map values, and the red map will have all the values apart from your current node and the ancestor. So let me write here. This is only possible because of the special nature of DFS. Now, guys, there is one more thing. See, Infosys asks such a hard problem. You need to maintain, you need to maintain a ordered set. Guys, in the hash map, मैं मानता हूँ, let's say when you reach, let's say when you reach this node I, the hash map is looking like this: X coming one time, this coming two times, this coming eight time, this coming zero time. But you need to know the maximum of these values, na? So maintain a set of sorted numbers, 0, 1, 2, 8, and keep on insertion and deletion again and again. So maximum frequency also you can query in a single go. So guys, can you see the complications of this problem? First, you need to have very in-depth knowledge of DFS. If you are in my course, 800-hour course, you will surely be a bacha at it. Then you need to have the knowledge of sum of I. Then you need to know how to mix it up with hash map and sets, and you need to know how to manipulate the value to get your job done. That's what Infosys wanted you for 6 to 9 LPA. But the nice thing is that if you're able to solve these kind of problems, na, you will surely end up in FANG. Okay, so make sure you solve these problems. Hope you guys enjoyed it. Love you all. This is my number. Whenever you face any problem, you can contact me on my WhatsApp number regarding your job issues, coding issues, whatever. Okay. Love you all, guys. Take care. The name of God, Ram Ram. जिसके साथ भगवान होते उसको आज तक कोई भी नहीं रोक पाया. राम राम.